Good morning, students. I hope you all are keeping yourself in good health. So, in the last lecture, we have read about chapter number 2, that is matter around us pure? Moving ahead with the topic, as we were reading about the chemical nature of matter. In the first chapter, we have read about the physical nature of matter. So, in this chapter, we are dealing with the chemical nature of matter. That is, chemically, the matter can be divided into two types, that are pure substances and mixtures. So, pure substances, as we have read already, are of two types, that are elements and compounds, that we have discussed in the last lecture. So, today we will be reading about mixtures. That is, mixtures can be classified into two types, that are homogeneous and heterogeneous. This also we have done in the previous video. So now moving ahead with the topic, today we will be learning about what are mixtures and what are the types of mixtures. So mixtures are the substances which consist of two or more elements or compounds or substances which are physically combined. So here I have written physically combined. Let me explain you this. Like any substance, when we mix together, when we mix two substances together, like if we mix sand and sugar together, so we will call it a mixture. Or when we eat any namkeen, you have seen very different namkeens at your house. When you have it, example, you're just having any different like groundnut in that, and then aloo bhuji and that, and different sort of, then we call it a mixture. That means in a specific packet of namkeen, you are having different types of namkeen in it, so we call it a mixture. Same way, when we mix different substances together, substances can be pure elements or the compounds together in any proportion. Okay, so we are not having any fixed proportion, so that is called as a mixture. But also in a mixture, they have just to be physically combined, not chemically combined. For example, if we take iron and sulfur, now iron is a metal and sulfur is a non-metal. So if we take some iron granules like iron powder and sulfur powder in a bowl together and we'll mix it, so we can call it a mixture. When we will run any bar magnet over that mixture, what will happen? All the iron fillings will get stick into the magnet, because iron or magnet always attracts iron. Okay, so that was a mixture which we can separate easily by any physical method, because in the mixture, the different things or the different substances do not combine chemically but only physically. Okay, now if we take the same iron fillings and the same sulfur, and then we will heat it. After heating, it will be a new compound which will be formed, that is, it converts into black color substance. Now if again we will rub or we will run the iron magnet, bar magnet over that substance, there will be no effect of the attraction of iron, because now iron has lost its property. It has become a new compound called as iron sulfide. So that is a chemical change. So when there is a chemical change, the thing is called as compound, because compounds are the mixture, or when the two different things combines. Okay, not mixture, when two different things or two different elements combines, like iron is an element and sulfur is also an element. So elements are pure substances, that we have read in our first lecture. Now the two elements will combine together, they will form a compound, and compounds are pure substances, they are not mixtures. But when we mix iron and sulfur separately by just a physical process, now I hope you understand what does the physical and chemical process or chemical change defines. Physical change are the reversible processes and chemical changes are irreversible processes. Okay, so now mixtures are the substances in which two different substances or the elements or the compounds combine together just physically, not chemically, in any proportion. For example, all the gases or all the air So we see air around us. So air is a mixture of gases. So there is a proportion, but that proportion also get disbalanced sometimes. But still we call it a air. Okay, the air is a mixture. Then salt solution, milk, many paint, etc. There are a lot of things which are called as mixtures. Okay, so mixtures can be of two types. That is, it can be heterogeneous mixture or a homogeneous mixture. So there are two types of mixtures, homogeneous and heterogeneous. Homogeneous mixtures are those mixtures in which the substances are completely mixed together uh, and are indistinguishable. Now, indistinguishable word defines that when we are not able to distinguish, that means when we are not able to identify what is the two different things. Like if we mix salt in water, after stirring it, what we see? Can we see the salt in the water? No. The salt particles completely dissolves in the water, and when we'll see through it, we will just see the plain water. So we cannot distinguish whether there is salt or whether it's a plain water. So the homogeneous mixtures appears to be a very true thing, true solutions, or they appears to be sometimes compounds. We will not be able to identify. If you're having a glass of sugar solution, if you'll just mix 1 teaspoon of sugar in water and somebody will ask you, just tell whether it's sugar in the water, you will not be able to distinguish by seeing. You can only distinguish when you taste it. Okay, so that is called as a homogeneous mixture. And when you will taste the that water with a spoon, it will taste little sweet. You can take any part of that water from that glass. The whole glass of water will taste as same. So that means homogeneous mixture means homo means same, and geneous means evenly spread. In the homogeneous mixture, the solute is evenly spread in the solvent. Now solute and solvent, solute is the thing or the substance which is mixed in the solvent, and solvent is a substance into which the solute is mixed. I will also give you the definitions of solute and solvent in the next lecture when we will read about solutions in detail. We are also having some numericals when we will practice that. So homogeneous mixture can also be termed as true solutions or solutions. Like solutions are the homogeneous mixture of two or more substances when we are not able to distinguish. Example, salt solution and vinegar. Vinegar means when you eat your Chinese food, you would have seen the your mother and or the person who is in the shop adding some vinegar into your food. So that is also a mixture, but it is a solution or a homogeneous mixture. Metal alloy example, brass. You would have seen brass. Now brass is an alloy. Alloy is a thing when we mix two different elements or two or more elements together without any proportion. The brass is, from example, when we mix copper and zinc together, the brass is made, which is called as alloy. But in that, it is a solution. That means all the particles are evenly mixed into each other. It is a mixture because we can separate them, and brass does not have its own property. So that is why we are not calling brass as an compound but as a solution, because brass is not a compound. We can also make brass by mixing different things like lead also, so it is not in any proportion. So brass is a mixture. Then pure air means a mixture of gases when there is no pollutant in it. If it will be having pollutant, it will be called as a heterogeneous mixture, but the pure air is just a homogeneous mixture. Okay, so solution is done. Now moving towards the heterogeneous mixture. Heterogeneous mixtures are those mixtures in which the substances remain separate and one substance is spread throughout the other substance as particles, droplets, etc. So in the heterogeneous mixture, when we mix the two different things, one thing does not mix completely to the other thing. Like In the case of homogeneous, the sugar or the salt is completely dissolving in the water. We are not able to distinguish. But in the case of heterogeneous mixture, the things will not dissolve completely. We will still be able to see the particles in that. Okay, so it can be in the form of particles, it can be in the form of droplets, it can be in the form of vapors also. So they are called as a heterogeneous mixture. Example, sugar and sand mixture, polluted air. Okay, polluted air has some suspended particles in it, particles of matter in it. Milk, ink, butter, cheese, muddy water, etc. Now milk has some particles of fat in it, particles of milk in it, and other things also. So it is a heterogeneous mixture. Now heterogeneous mixtures are again of two types, that is colloids and suspensions. Now colloids are those solutions, are those mixtures in which the size of solute, again I'll repeat these words, solute and solvent. So solute is the part or the portion or the substance which is mixed into the solvent. Like if we mix sugar and water, so sugar is mixed in the lesser quantity in the water, so sugar is called as solute and water is called as solvent. Okay, if we make ink, so we will make some dye into the water or a liquid, so here dye is the solute and the water is the solvent. Okay, or example, in the milk the fat particles or the cream is the solute and the water is the solvent. Okay, so now in the colloids the size of solute is little bigger than the size of the solute in the case of true solutions. Like when sugar dissolves in water, the sugar becomes so small, the particles of sugar become so small that it can hide in the intermolecular space of the water. Okay, but not in the case of colloids. They are a little bigger than the size of the solute of the solution, so they can be seen easily. Example, soap solution, starch solution, milk, ink, blood and jelly, all these come under the colloids. Now colloids also have some tendency, that is they show Tyndall effect. Now Tyndall effect is the scattering of light of colloid particles, that is known as Tyndall effect. Now you would have observed that in the winter sometimes when you travel in the dark or in the night, uh, okay, when you're traveling with a bike or a car at night, when there is a fog all around and when the headlights of your bike or of your car goes, you can see the beam through a longer distance. So the visibility of that beam is due to the presence of some fog in the dark night. So that fog behave as a particles of colloid in the air, and because of that you can see the beam of light. So the beam of light, the process or the scattering of light is called as Tyndall effect. So basically that is the Tyndall effect. In the daytime you are not able to see the beam of light because there are all the air around us, but when you sit in a room and there is a little ventilation corner in your room, you must have seen the ray of light entering to your room. So that is because of the, that is called as the Tyndall effect. And since the air around us it's not very pure, it has some particles in it, it's a heterogeneous mixture, so we are able to see the beam of light. So air basically is a colloid. Okay, when there is a storm it is called as a suspension, but a natural air which is around us is a colloid. So colloids have this property to scatter the beam of light, which is called as a Tyndall effect. Okay, so I would like you to show you a diagram of Tyndall effect. Now this is a beaker. In this, if we will scatter a beam of light here, so here in this beaker is water and drop of milk. If you will be adding a drop of milk into the beaker in the water, it will behave as a colloid. So when we pass beam of light through this, the beam of light is okay, in this case of a true solution, first of all it's a true solution, so you can take anything, like you can take a mixture of sugar and water. The beam of light is not visible through this water. You will not be able to see the beam of light, although you will see the light here, but you will not be able to see the beam of light passing through the solution. Okay, because true solution does not show Tyndall effect. But in the case of colloidal solution, so here we will add some milk drop in the water, and then you will pass the beam of light through this beaker. You will easily see a beam of light crossing to this beaker. So this is called as a Tyndall effect. So the beam of light will be visible in the colloidal solution, or this is the soap solution. Actually, you can also take any solution like ink in the water, or milk in water, or anything like that. So colloids show the beam of scattering of beam of light through them, which is called as Tyndall effect. Now, suspensions. Suspensions are the heterogeneous mixture in which the small particles of solid are spread throughout the liquid without dissolving in it. Example, if we will take sand and will mix it in the water, the particles of sand will not dissolve in water, and they will be spread all throughout the liquid, and they will not dissolve. So that is called as suspensions. So chalk, water, again, mixture of chalk and water is a suspension. If you will mix the wheat flour in the water, it will again form suspension. Muddy water or milk of magnesia is a base, it is also called a suspension. Sand particles in water, so they all are called as suspensions. Okay, so I will like you to tell you in a detailed version. Here I have made a chart. In this I have written all the details. I have just differentiated all three things together, that is solutions, colloids and suspensions. So here first we will be discussing about the how kind of a mixture are these. So solutions are homogeneous mixtures, okay, because they just are evenly spread in the solution all throughout. Homogeneous mixture. Colloids are, they appears to be, remember this point very well, they appears to be homogeneous, but actually they are heterogeneous. Though there was not a big much space, so I have just written very in a concise manner. Please try to read this. So colloids appears to be homogeneous, but actually they are heterogeneous, and suspensions are heterogeneous mixtures. Okay, first point. You can also make this table in your notebooks. So solutions, the size of solute particles is extremely small, that is less than 1 nanometer. It's 1 small n and small m. It is less than 1 nanometer, that is 10 to the power minus 9 meter. Okay, so that is a very less size. So the size of solutions, please do remember, learn all these points, they are very important, also important for exams as well. So colloids, the size of solute, actually we are talking about the size of the particles, because all these are solutions, not these are true solutions, these are colloids and suspensions. So in the case of heterogeneous mixture, the two different things are mixed together, or in a liquid, not all the times in the liquids, but we will also study about the solid into solid, or gases into gases, or liquids into liquids, or liquids into solid, or liquid into gases, or solid into gases, and solid into liquids. So here if we will mix solid into liquids, so the solid portion, so the particles of solute are, whether they are this, we are talking about the size of the solute particles. So the size of solute particles are very small, that is less than 1 nanometer, that is 10 to the power minus 9 meter. So in the case of colloids, the size of solute particles is larger than the solutions particles. It is between 1 nanometer to 100 nanometer. It is 1 nanometer to 100 nanometer in diameter. And in the case of suspension, the size of solute particles in suspension is larger than 100 nanometer. Okay, so remember this point. Now next point is, the particles of solutions cannot be seen in the microscope. They are so tiny, they are so small that we will not be able to see them by our normal eyes, but also we will not be able to see them even under the microscope. So they are not visible. The particles of solute are not visible at all. In the case of colloids, the particles of colloids can be seen under the microscope. So if we talk about milk or ink, we will not be able to see the particles from our normal eyes, but yes, we can see them under the microscope. And in the case of suspensions, we can easily see them by our eyes. Like we can easily see the particles of sand in the solution or in the mixture of water. Now next is the particles can easily pass through filter paper. So if we will filter, we will not be able to filter them because all the solution will pass through the filter paper. So the size of the particles is so small that they can easily pass through the filter paper. Here in the case of colloids, the particles also can pass through the filter paper because the size is not very big. It is little bigger than the solutions but not as much big, so they can also pass through filter paper. Have you ever thought of filtering milk? No, you cannot filter milk now. It will all pass through the filter paper. That means the colloids particles can pass through the filter paper. In the case of suspension, we can easily filter them because they cannot pass through the filter paper. If you will filter the muddy water, so obviously all the mud will be strained on the filter paper. So the particles of suspensions cannot pass through the filter paper, whereas the particles of solution and colloids can pass through the filter paper. Next is the solutions are very stable. That means they are always stable. That means they do not separate. Okay, the solutions, like if you're having a glass of water and then you mix a tablespoon of sugar in the water and you stir it well so that all the sugar is dissolved in the water, and you keep it aside for 1 hour or just for a full day for 24 hours, and then next morning you will check that taste that water, it will taste same all through the glass. If you will keep that water in a plate, okay, and then you will drink from any other side, the water will taste same. Is that it happens because the particles are very stable, so they just evenly spread all around and they don't collect. Okay, so that is in the case of solutions. So and same in the case of colloids also. The colloids are quite stable, whereas the suspensions are unstable, so they keeps on moving. Okay, so the particles of solutions do not separate. They do not separate from each other. They just mix all around the area they are mixed into it. Colloids also, the particles of colloids do not separate out on keeping aside, on keeping still, on keeping on standing. If you'll keep it on rest, the particles will not separate. They will just they will be distributed evenly. But in the case of suspensions, the particles of suspensions settle down. If you have a mixture of sand and water and if you keep it aside for a few minutes, it all the particles of sand will settle down in the bottom and you will get the clear water on the top. Okay, so they are bigger in size, so they are heavier and they have effect of gravity, so they settle down. These do not have any effect of gravity on them. These also do not have any effect of gravity on them. But yes, in the case of suspensions, they do settle down. They have the effect of gravity on them. Okay, now the last point is this: the true solutions does not scatter light. That means they do not show any Tyndall effect. The colloids show Tyndall effect. That means they scatter a beam of light passing through it. And here suspensions. Okay, now since we have said in the beginning that the size of suspensions is larger than 100 nanometer, but yes, it can be to 100 nanometer when it is nearer to the colloidal size. Sometimes, only sometimes, it may scatter a beam of light. So we cannot say completely no to this, but only if the size is towards the colloids, only then it will separate the beam of light, scatter the beam of light. Otherwise, if it is bigger than that, it will not scatter the beam of light. So they are called as suspensions. So this completes your topic for today. In next lecture, we will be reading few more things about these things and also some numericals. So till then, do your work properly and stay safe at your houses. Thank you.